Hey everyone, welcome to this week's seminar. Chauncey Frend from the AVL Advanced Visualization Lab will be presenting today, talking about augmented reality and all the ways it can be used. And so Chauncey's been doing augmented reality for at least 5 years, I think.
More than that, I started grad school in 2010.
Since 2010, all right, so that's what we learned.
Thank you. So thanks for everybody for coming today. I know it's a busy time of the semester, and I appreciate you guys being here. So we should have some fun. Hopefully I can get you guys some useful information. Yeah, augmented reality is a topic near to my heart. I did my graduate school work in it, and I've been working in the Advanced Visualization Lab, UITS, for 10 years now. And periodically, augmented reality is a topic we focus on, and it seems like the technology is rapidly progressing in the commercial market. So Apple's making a big bet on it, so is Microsoft and several other companies. So these are big Fortune 500 companies, and they influence kind of our daily lives and how we interact with computing. So it's an important topic to pay attention to. Maybe there's some tools available to you even today that you can make use of. But I will make kind of an overarching statement that augmented reality doesn't necessarily have kind of a home yet, like a mainstay device that I can point to and say, that's an augmented reality device. There's lots of devices, sort of non-standardized. So I've got a spreadsheet up here, and there's one more talk in the series happening on the 21st. See that here? John Rasick, students.
Also, Juliet Gniady is from the Eskenazi School, Eskenazi Art Museum.
So Juliet's from Eskenazi Art Museum. For the folks on the mic. And then next week, the Augmented Reality Expedition canceled another event that's going to be happening. And I forgot to touch that screen. So today we're going to get a little bit of acquainted, do some basic things just here into introducing you to augmented reality. I'm sure everyone here knows what it is. I'm going to assume that. It seems to be very popular. Who doesn't know what it is? Yeah, good. That's what I thought. What about people who, anybody here use augmented reality? Yeah. Well, yeah, that's augmented reality. Maybe Pokemon Go has some augmented reality features too. Anybody else? Maybe program augmented reality? You don't have to. Not necessarily just a programmer's tool. But what's interesting about augmented reality is the relationship it has to other spatial technologies. So we view this on a continuum. So I call it Milgram's continuum. Someday we'll look back at this era and probably define a name for this. But the reason I use a continuum is because you can state on one side is the real world, on the other side is completely synthetic world, virtual world. And then when you start to blend them anywhere along this middle area, you get different names of things. But ultimately, you can just say augmented reality. Most people that study the topic or build tools for the topic know what you're talking about. You might hear out in the industry mixed reality, or virtuality, or there's all kinds of other commercial names, and that's literally where they're coming from. There are other people coining names to sell products, to copyright names and sell products. Like Windows refers to their HoloLens product as a mixed reality device, and they have reasons why that is. It makes use of the spatial environment more. So it's up for debate. Moving on, this is sort of my perspective's view of the history of augmented reality. So kind of starting back, it was imagined first in literature, as many computing topics are. And moving forward, the history sort of comes and goes. It ebbs and flows with released tools, abilities for people to empower themselves to build some augmented reality in some sort of case. So I sort of entered into it around, let's see here if I can find it, 2009. Okay, I worked with the School of Informatics in Indianapolis. I'm based in IUPUI. And as you can see this image up here, this was sort of a viral demo, this one with the wind turbines. You can actually blow on the microphone and the wind turbines would animate based on the amplitude. But it was run through a web browser, so it was very accessible. I think GE funded that effort, and they used the Flash player, which is hardly on the internet anymore. But that was a workflow. They took the AR toolkit, C++, back-end programming to do augmented reality on a picture, anchored onto a picture, and render graphics on top of that. So that was very interesting and sort of got me going in this space, mostly from just a programmer's perspective. And then, there's products announcements that get the hype train kind of going. So we've heard of Google Glass, right? Then the HoloLens. Who here's used the HoloLens before? No. I've got one here today. I'd like to try it. Pokemon Go made augmented reality a household name. Okay, so that's a good takeaway. That marketing helps. Okay, and there's going to be all kinds of other things that come soon that would basically truncate this list to almost nothing, because, like we see many times, new products come out and then go viral or get popular, and everyone says that's when it started. Virtual reality started with the Oculus Rift. Well, honestly, it's been around for a long time. In fact, there's an image here of the first headset called the Ultimate Display here, which actually was see-through by Ivan Sutherland, University of Utah. And that system, you could see the real world and put computer graphics into the real world. That was using cathode ray tubes, and it was mounted to the ceiling. Pretty interesting how far back this stuff kind of goes. All right, moving on. So in terms of usage of visualization facilities, we break everything up into 3 types. Today we're speaking just about augmented reality. I'm going to be referring to this throughout the entire presentation. Okay? So, it looks like sort of a boring slide, but trust me, this is pretty important stuff here. So imagine if you're trying to use augmented reality, where do you start, right? Do you find an app that's already made and you just use the app? That's what we call type 1 use, where someone's already made it for you, the data's already there for you, and it's the easiest way to get going. You go on the App Store, type in augmented reality. There's literally hundreds of AR apps now that you can kind of download and play around with, free, some are paid. Type 2 is another type that we call like kind of the sweet spot. So this is where an app is already created for you, but you put your own data in it. So imagine you augmenting your own stuff over the real world. Why would you want to do that? That's sort of the entry question on why you use augmented reality. Why do you need data in the real world? Some people just do it because it's cool. That's valid to a point. It gets you so far. If you want to make augmented reality a tool, find the utility in it. You need to relate the data to the real world somehow. It needs to make sense. You're on Snapchat, you're matching it to a person's face, and you're flipping through the different filters and trying to find which one sort of you want to actually take a screenshot of and put on social media. Or if you're looking at a museum artifact, you got to make sure the metadata relates to the artifact that was augmented on the surface. See what I mean? Type 3 is what most people assume that you have to do, which is build something custom from the ground up. Anybody here a Unity developer? No, really? Okay. Well, I'm a Unity developer, and I have a vast community of other students that I know of at IU that develop with Unity, and we're all very much guilty of this diving into Type 3 because we find comfort in having full control over the design. Problem is, this is really a long process to write your own software. And not always something you should engage in every project that comes up. So if you guys get into working with augmented reality, just consider that you can find things available where you don't have to necessarily do everything yourself. These are some examples that I use today. This one was created by a student with myself as a mentor back in 2015. I'm going to see if I can get this going. It's a YouTube video. There we go. Actually, don't need sound for this. So the problem here was that the students in this mechanical engineering technology class had to produce the parts for the steam engine. So they're learning how to work with milling machines and lathes and various mechanical fabrication tools. And they couldn't really understand the blueprints into 3D space very easily. So to help them with that, Samantha here worked with me, and we created a visualization using cell phone basically to recognize the blueprints and then augment the part to scale on top of the blueprint so that folks could use it as a reference. So really good use of the the utility of augmented reality, because it's nice to be able to put the real world parts and the blueprints together kind of in the frame of your cell phone. It's not like an immersive experience, like some might imagine, different types of augmented reality that have been science fiction, but it is useful. All right, we can come back to that. Next one I want to do here is this one I produced for UITS at the Supercomputing conference a couple years, or actually it was last year. Getting ahead of myself. So we have these IQ walls as we're presenting on right now, and they can actually be designed to be rearranged. So you can actually kind of slide these around and build exhibits with them. And as we're showing on all these different pieces of perforated cardboard, you can look at them through a HoloLens or through a cell phone and actually see different designs on how you might lay out an IQ wall and use it for visualization. That way we don't have to actually move the big expensive IQ wall that's behind us all the time and show people rearrangements. We can just sort of see it as data. We can even augment one full scale. So I'm going to fast forward to that part of the video. There we go. So big one. And then I throw a marker on the ground, and that anchors the graphics. And that's 2 scale. I did next. See that? So people that are walking by were just like, what is this guy doing? So just sitting there with his tablet, staring out into nothing. Is he taking a picture of what's going on? And we find this a lot with AR and VR. It's a party for one. A lot of times you have a headset on, or you're holding a tablet, and the user experience is built just for that individual user. The last example I have for you is a research project done by Tyler Jackson. Tyler was an intern in our laboratory for the last few years. He's moved on recently. And Tyler was studying digitization, so the concept of 3D scanning real-world objects. And one of the problems is after you successfully 3D scan an object, if you want to represent it in virtual reality or augmented reality, how do you do the lighting on it so it matches the real world? And he was focusing on augmented reality here. And what he did was he put a 360 camera in this box. So there's a real world object he digitized on the left, and then this is a 360 repo theta. And he's collecting all the image from that, streaming it to his PC, and then he's got some Christmas lights kind of embedded in that soft box. And then on the touch screen, you can see the augmentation. So you see on the right is a synthetic version of this model. Sorry about the jumping video. I just filmed this on my cell phone because I wanted to get it documented somehow. And as he clicks the buttons, he can actually change the color lights around the outside here. So he's doing light estimation, essentially. He's taking in light and using the camera instead of as a camera, but as a sensor for colors, temperature, contrast, things like that, and then processing that into 3D space for the lighting on his object. So going back to the types, I want to highlight to you guys some good examples from type 1, 2, and 3. So you guys all have access to this stuff. Just go to, I searched AR Core app, AR Kit app here, just because of the sort of dichotomy between Android and iOS. And what we're looking at here are just image results. And you can see it's just a vast number of apps. I honestly can't say what is the best thing to grab. It depends on what you're looking for. So if you just go to your favorite app store and search for augmented reality, you're going to find AR Core or AR Kit apps. These make use of your camera's 3D tracking capability. Most modern devices, going back to I think 2017, maybe even a little earlier, will work with this. So it's just a software update, not a hardware update. And then all new phones coming out just keep getting better and better at doing this. So that's something to consider. If you have an idea, you're like, I wonder if there's augmented reality already out there for that, just search it. I implore you to just search and see if there's something there. Type 2. So Sketchfab is a tool that you can upload your own 3D content to. So the Advanced Visualization Lab and Digital Humanities, we teach lots of folks and empower lots of folks to digitize 3D objects. So what you're looking at here on the right is an elephant we use for training. So this is a hand-carved elephant from India, one of our former staff gave to us. And what you're seeing here in the middle is the real carved elephant, a 3D printed version of it after this 3D scanned and printed. And then this is a Sketchfab augmented version of the elephant. I'll go ahead and just sort of bring this up for you guys to see how easy this is. So I'm launching the Sketchfab app on this Android tablet. And search just about any object. And I'll just pick one at random. This is a watch. It says it's a large scene, so be careful. It'll take a long time to load. And what it's going to do first is switch on my camera view and start looking for flat surfaces. Since it's a large model, there we go. So what you're seeing here is just these like annotations on, oh, it detects a flat surface, the floor. And if I tap, we can place the watch. Now this isn't that useful, just kind of cool, right? If you had this to scale, it might be useful. You might consider that you can upload something to Sketchfab on the app, load it on your device, and augment things. So if you're doing, say, a furniture design, you might just upload the entire furniture design to Sketchfab, get yourself registered in the location where the furniture will go, hit locate, scale it, rotate it with your touch screen, and there you go. You've augmented a space with basically no programming at all. That's a type 2. Okay. So AR platforms are very diverse because there's lots of ways to put data into the real world. I've been using a tablet. You can use your cell phones. There are more advanced tablets and cell phones that are meant for augmented reality specifically. And here we have just a laptop. You can actually do kiosks, things with webcams. And at IU, we basically call this bring your own device augmented reality. We basically rely on you to supply your own equipment to do this. And I'm not saying that necessarily we have all these other emerging platforms available, but these are things to keep an eye on. As you get into this area, and as you guys maybe want more sophisticated augmented reality, wherever you end up in your career, there's a lot of action in the commercial space for emerging augmented reality platforms. And, I work with lots of different software development kits. And literally one I was using called Meta.io for a while just disappeared overnight because Apple acquired them. So if they're buying up companies and then shutting down the developer front ends, and there's rumors, and I think the CEO of Apple, named Tim Cook, he mentioned on Good Morning America that he's way more excited about augmented reality than virtual reality. That holds a lot of weight for a developer like myself. So if we get a product from one of these massive companies that is for the consumer market, we might see a shift in how people use computing and the internet in general. I mean, a lot of you probably speculate on what the future holds for augmented reality. I would say the consumer space is just sort of primed and ready for the right tech to come along, the right design. We have a lot of enterprise systems that work really well. The HoloLens works quite well if you're willing to accept its limitations. And I want you to try it today if you're interested in what that means, the limitations. It's hard to describe. The HoloLens 2 is also available. They actually just emailed Bill today and he told me, hey, I got an email that HoloLens 2 is available. These are a little bit cheaper and a little bit more capable. Magic Leap is another device that's very similar to these two. So this one uses lasers to 3D scan what's around it. Then they shift it to cameras, okay? And then Magic Leap uses cameras. So what that means is the way they sense the real world is all kind of varied and different. And I'll get in more detail into that later. Projection mapping is another type of augmented reality. Right? You're just putting data, graphics into the real world. And there's a really, really unique tool called Lifeform I wanted to highlight today because this is made by a former Disney Imagineer who had done projection maps in theme parks. And he released this as a startup company in LA, and we got tons of funding, and it's doing quite well. And you can order these and mount them on just about any projector. And it basically builds like a Photoshop interface for you based on what it sees. And then it tells the projector how to calibrate, kind of under the hood. And again, no programming required. Quite a really unique system there for projection mapping. So you can imagine augmenting, a marketing exhibit or museum exhibit. So tracking systems are sort of the dirty little secret in terms of getting yourself going with augmented reality. When I say that is, this is where you get basically the limitations that hit you every time. If you have an idea where you want to put data in the real world, why can't I just augment my car? Why can't I just augment my dog? You know, there are reasons why, and it mostly comes down to the tracking system that's available. And the tracking system, you know, in a nutshell, is just the computer that's running the augmented reality needs to know what's happening in the real world. It's got to track some part of the real world over and over and over again so that it can match those graphics or sounds or whatever is being put into the real world that's synthetic. So we see basically the most successful breakdown here of tracking systems. I guess not the most successful breakdown, but most successful tracking systems out available now. And unfortunately, like I mentioned earlier, there is no single augmented reality system that does it all. So I can't necessarily say use that device because it does all these forms of tracking. But as an analyst, my job is to basically break it down for researchers to let them know that, you know, it's okay, you can do augmented reality, you can only combine hand tracking with GPS, right? You can't do hand tracking, face tracking with GPS for some reason. Usually this is caused by the systems that are just available. So anyway, let's do a little bit of an overview here. So marker tracking is one of the most common, the earliest forms that was very reliable. It's still pretty reliable. All this comes down to is computer vision. So computers a lot of times have cameras hooked up to them. Cell phones have cameras built in. HoloLenses, they all have cameras on board. And you can process every frame to attach computer graphics to with like QR codes, all these fiducials. You can do just a regular 2D image. Or you can use sort of like what it looks like from a 3D object from different directions, kind of get a computer to attach graphics based on those sort of tracking abilities. We've all probably seen different forms of face tracking with the social media apps that do it. A lot of cell phones now come on board, what Samsung does, with some face tracking, augmented reality built into the operating system. Pose tracking is another type we use a lot in performance art. You're tracking a person's entire skeleton, just like basically how their body's moving, and you can project on them, right? Hand tracking is utilized quite a bit in virtual reality, but it's useful in augmented reality as well. Location tracking is something that everyone assumes works for augmented reality. It doesn't really, unless you kind of understand the context and the limitations. So GPS, you're going to get within like a meter, but for computer graphics, you really want the registration of your data to be right on the object. So it's tricky to use GPS with augmented reality, but you can do it. You can have a lot of times wayfinding apps where you put bubbles up in the air that are tagged geocoordinates. There's if anybody's a developer, I would say look at Mapbox. It's a nice, fully featured suite of tools to do location-based augmented reality. There you go on and on. There's lots of tools for this stuff. And then sort of the big, amazing lurch forward in innovation is this area on the left, area alerting. This is something that, like I said, they upgraded your cell phones to just a new software update and enabled area alerting. And I'll get more detail on what that means, but there's sort of breaks out into two segments. There's the ability to understand the 3D shape of the world. We call that SLAM, simultaneous localization and mapping. It's not important that you know that. It's just, if you hear the word SLAM, that's what we're talking about. It's just your device understands the topology or 3D shape of what's in front of it. And then flat surface recognition is a utility within area alerting that I just demonstrated for you. Remember I was looking at the floor? Sketchfab app? There you go. And then there's another emerging area in tracking systems that's popping up soon, thanks to artificially intelligent computer vision algorithms that can look at a scene and has been trained to understand lots of people, places, and things, and can just do node tagging on objects to say that's a dog, that's a cat, that's a person. And then to do, you know, deeper dives into that data is just another monster. But there are augmented reality packages that will, you know, you look around on a desk and there'll be a coffee cup, pencil, pen, that sort of thing. So once a system understands the real world, you're in business. It's time to put data into the real world and attach it. So then you have to constantly update that stuff, the location of that stuff. So what you're seeing there is something I shot with the HoloLens up at IPY there on the right. And it's just showing you the tessellation mesh, which is just the 3D mesh of that room. So I spent some time prior to recording this, walking around with the HoloLens on my head, literally looking weird, just like staring at the floor, letting it understand, caching information. And then here is just showing you through the spider web what it ended up with. The one on the left here is just sort of an artistic expression of what the HoloLens can do. It's really impressive. This algorithm came from the robotics industry and came into its own for autonomous vehicles. So if you have a camera on your car, a lot of times it's actually capturing 3D shapes of things and trying to make detection happen for safety reasons usually. But the Tesla vehicles now, they have like 7 or 8 cameras on them, and they are doing SLAM tracking on their vehicles, not for augmented reality, but for autonomous driving features. So type 3, if you are willing to go the distance and teach yourself how to program your own augmented reality apps and have full control, good on you. But I mean, I won't necessarily recommend this for everyone. But we caution folks against this because of how much time it takes, but it is a lot of fun if you get into it. So I'm sort of outlining here, the Unity package itself is the base package, and there's plugins that go along with it. Euphoria is the one that I introduce a lot of folks with. I have a tutorial I'm going to share that I made on YouTube that you guys can check out. It's like less than an hour long, and it just explains how to get Unity running with Euphoria and augment images on just about anything that has contrast. So like this video card I'm holding, launch my Unity app. I've got metadata that goes with it. Oh, thank you. Yeah. So this still holds that card there. I've got a couple buttons that pop up on top of it. It's just recognizing with Euphoria the image. If I click on the interface, now we have the metadata associated with that. So wattage, more buttons, speed. Yeah, and Bill can move it around. This is an example of image tracking. Was that? Yeah, go for it. It's actually a YouTube video. I didn't cover this. And then there are other plugins that go along different lines. So if you want to just augment fiducials, you can use AR Toolkit. That's another plugin for Unity. It will also work with desktops and laptops, whereas Euphoria will not. It's only for mobile devices. And then there's the Microsoft HoloLens plugin. And there's actually more not represented on this slide. There's AR Foundation, which sort of combines AR Core and AR Kit's features. AR Core and AR Kit are actually plugins for Unity. They actually come with Unity. So you can learn Unity on Pluralsight or just on YouTube. I think when I first got into it, I went on lynda.com. I spent one solid Saturday and Sunday. I learned the whole package, and haven't turned back. I really do love that system. It's pretty useful if you want to learn it. This is a type 3 project example. So Hannah Campbell was a fine art student in Indianapolis at the Herron School of Art. And she came to our lab saying, I need to make holograms because I can't afford to build my exhibit for my final project. And she was designing a furniture system. She ended up doing in her career. So she was using 3D printed connectors and then just nice plain wood pieces connected together. Instead of me babbling, let me just show you kind of what came out of this. So if you came to the exhibit, she had limited versions already all printed out and mounted. But to see everything else, she had an interface here that she made. This was for her mostly an exercise in animation. She had a movement sort of explain the connector system. I was able to help her get this going in Unity without any programming at all. It was just sort of like putting her data in, making sure the animations work. It wasn't like just kind of drag and drop and done. It took her several iterations to figure it out. But once you start, you can kind of sort it out just by play and iterations. Doing things to scale is also something people take for granted. So when she brought this in, luckily she had modeled it at scale, but a lot of times you're going to access 3D models and shapes that especially if you use photogrammetry. They're not to scale. They'll show up and they'll be like 3 miles wide. It's actually just something that was this big in the real world. And you have to sort of mess with scale. So it's important to pay attention to those units and sort of control the scale as you're working. But as I showed you in Sketchfab with the augmented watch, you can kind of, inside of that, just kind of scale up and down by pinching, spreading your fingers. Right. So I have support for type 2 and type 3 on YouTube, and we're actually proposing to do more of these. We certainly would like to hear from you as far as like what types of augmented reality you're looking for. That way we can put together documentation to help you and others with the same needs. And one of the things that I like to talk about in augmented reality, since we're putting data in the real world, often the data looks like fake and extra in the real world. But as we digitize objects from the real world or record what the real world looks like in dimensional 3D scans, you can actually probably augment things that look someday like you couldn't tell if it was real or fake. So this is an example of that. We digitized this bloodletting bowl. I've got it on my desk, and I'm augmenting it on top of the real one. So I'm kind of tricking the viewer in this video. You'll see me shift in Unity here the object. And it's almost indistinguishable from the real one. I'm using some artificial lighting to make that happen that matches the lighting in my office. We're doing object 3D tracking there. So if I fast forward this, you can see why you might want to do this. That's a barber's bloodletting bowl from the 1800s. So I'm annotating with information. And instead of me using that colorized 3D model, I'm using the invisible version of the 3D model. What it allows for is this special feature called occlusion. So you can see if I turn the bowl, hopefully I do it, I have to rewind the video. It's me explaining the bowl. Here we go, right here. See that right there? Where I'm blocking the text. Most people would say, well, that's what it should do, right? Let me go forward. Without the occlusion layer, what ends up happening is when I turn the bowl, the text will appear on top. So that's correct. That is incorrect. See that? It's a small distinction, but users will not accept that eventually. They'll say, no, why is this not occluded? It says this in front of the other. That's the point. So, that's a tricky little concept in augmented reality, is that you're going to have to pick up things with your tracking system that are in the foreground and background and midground, and also make sure your graphics kind of come and go in place of, or in and amongst those, if that makes sense. So, some interesting optical things there. I've got a couple tutorials that you can find on our YouTube channel here. These are type 3 efforts, by the way. Learning how to use Vuforia with Unity. There's also an introduction to Unity on there, and HoloLens publishing. And the Sketchfab one, I don't have a tutorial for, but just trust me, you can download that app. It's very simple to get going. And like I said, I do want to hear from you as far as like other topics you'd like to have available. We have I already announced this earlier, the expedition for next week has been canceled. And then you can contact our lab, lab-wide. Lots of us are specialists in different areas. I just happen to be a specialist in AR and VR. And Bill Sherman here is a specialist in VR. And there's folks who are in CyberDH who are specialists in digitization. Just ask.
Did you have a calendar on the last one? I'll go back to the calendar at the beginning. So the talk in 2 weeks is actually going to be examples of augmented reality applications. One by Juliet from the Eskenazi School or Museum, and then Michael Chaga and John Rasick, who are professors and use it, and they've had a project they've been working on with students. And so they'll be talking and demonstrating their stuff.
Awesome. So I purposely left quite a bit of time for questions and demos. So for those on Zoom, I'm going to let you go, and then we're going to open this up. Well, that's true. I guess we should do questions before I let you.
Katie's got questions.
All right, fire away. On Zoom first, and then we'll do any questions. Any questions on Zoom? Okay, cool. Adobe Max area. Let's take a look. AERO.
Yes.
Cool. Yeah, Adobe is an interesting publisher for software because they're all about creative enablement, right? Their tools are not for programmers. I think I have seen this image here on social media, so very cool. Yeah, that's definitely something I need to check out. If there needs to be tutorials, I'll see if I can put something together. Another, you've seen this light up. Okay, cool. Anybody else? Okay, so I'm going to have a few demos out there. The one that I showed you guys with supercomputing IQ wall visualization I've got here. And we can run that from the tablet and from HoloLens. The thing is, I'm going to let a playlist roll. There's a whole bunch here. If you guys want to try this, I'm just going to leave 3 pass it around. You just basically aim it at this. One of the things that's interesting as a software developer is this stuff takes a lot of time. You guys might appreciate this. I put an Easter egg in this app. So if I aim up, there's a hidden button. And in the air. Let's put it over by Matt. I aim up in the air. Hidden button right there. I'm a big Metallica fan, so. That's kind of a cool principle. Just put Easter eggs in spatial environments. Have fun with that. And then I'm going to get this HoloLens going. Does anybody have any questions? Oh, nothing?
In terms of like intertextual parts, do you find that the scale can be represented like pretty accurately, or is that
Yeah. What's neat too is like the 3D engines themselves, they'll tout like what their native units are, like unities and meters. Okay. So like I'll just start with like wherever the source data is coming from, do a conversion. Okay. And then once I do that, a lot of times I'll actually augment what would be a 1 inch, right? Yeah. And then actually get my real ruler out and measure that, see if it actually is 1 inch. Then I know, okay, reality and virtual reality are mixed together now, and it's to scale. And then that's when you make, it's basically your baseline, and you know it's going to be accurate. That elephant that I showed you, like there's no way for me to know that was the scale because Sketchfab doesn't provide the ability to measure. But I just arbitrarily scaled it.
just like well, the measuring tool on the iPhone?
So like AR Core or AR Kit is how they're doing it, right? It's like it's doing slam tracking, and then like when you the screen, it fires an invisible raycast down into the world, and it intersects with what it understands of the real world. And unfortunately, our phones are all different in terms of their capabilities to do the AR Core, AR Kit thing. So like if you have an older phone, man, the measurements are way off. Yeah. And so that's sort of a nice little vertical for companies that do like home installations and furniture and stuff, is they can like they can get access to your 3D space, let you augment it or measure it. But it is weird because it doesn't work the same for everyone. I was at a company that does like insurance investigations on Monday, like not investigations, I should say inspections. And what they had was like a training tool for inspectors to like look around, and you can like lay out where the house was, and then it'll alert you and say, hey, check on this part of the window because you're going to find that there's going to be a problem here. And it just reminds the inspector about little details that they may not be thinking about. Maybe if they're a new inspector.
Interesting, because at Campbell started here our interior design, so we're really familiar with virtual reality, like creating your space.
Are you in John Racing's class?
Not currently, but we've all had John Racing before.
Excellent.
Yeah. So
it's awesome. So have you guys tried the HoloLens yet?
no.
Okay, I'm gonna just put some random holograms in here, and then you guys can play around with it. So they've 3D scanned like different actors, and I'll just place like putting a spaceman up here. This was ballerina right here on the table. And they're animated, so like if you look at them, and then you do this gesture I'm doing, because the HoloLens understands gestures. Hide these 3 fingers, and then you tap, and it basically sends out a raycast, like a mouse click.
Yeah.
And I'll put one more. So they have an animated dog out on the floor here. That'd be kind of funny to see a really big dog. Here we go. I'm gonna pass this one. So when you put that on, just put the nose piece on first, and then take it down to the back. So like you can loosen it. You might have to put your hand on backwards. Sorry. Try it. There you go. So it might have part. That looks tiny on the table. I did put the really quick. And there should be like a. Normally, I get this streaming up to the screen. You can actually log into this thing. It's got a server on it. It's not connected to iSecure. I don't know what happened, so I have to look at it again. But that's what's kind of neat with the HoloLens, that you do a presentation for like John Racing's class. You could get it all set, right, and then have it stream up to a screen that you can see the augmentation, or you could just do like a recording of it on the screen. You see anything? Okay. So move it around in your face to make sure that also you get your eyes like that. There's a knot in the back. Yeah, it's that.
My head is so small.
They have these little smaller heads. See nothing. Do this. Take your hands off that. Anything weird? Yeah, so that's the start menu. That's like this when you click start. No, you can leave it. I just want to make sure you can see that. It's not put it away, do the same gesture. Okay. Now look here. Sometimes what happens is the HoloLens gets lost. It's like, I don't know what I'm looking at. Still see nothing. Okay. Here.
I just like there's that white.
What is that? Okay. Can I borrow it back from you? One thing that when I showed this to my wife for the first time, she had trouble with is she was looking at the object and she's like, I can't see anything. And what it was the field of view of the HoloLens is like a rectangle right in front of you. It's not your natural vision, which is VR. So she was looking like underneath where the graphics were, and she could see the dot. It's really important to sort of like do this, see. So I know for sure I can see the ballerina there. I can see this space, and the dog is huge up here. So try when you do it, just look right over there and just sort of move it up and down. Yeah, it's not natural. This is one of the limitations of the HoloLens, is the field of view is too small. And it gets to be somewhat immersive because it's stereoscopic and you can move around the objects, but their manufacturing limitations cause them to have a device out that is much smaller. The HoloLens 2 has a higher vertical resolution, but not much wider. Hey, Chris. Hey. Everything's working fine. Chris is our IQ wall master. He built this thing.
Did I miss anything?
The talk. It's not a talk you haven't seen before.
No, I got a text right before leaving that the data center wall
Yeah, right.
had a problem. We don't know what caused it, but it's happening now.
It's like a speed there on the
Yep.
board. And I walked down, and I walked down. And I thought, oh, I should grab that, and I forgot about it. And then I had to.
So let's watch a video about Adobe Max.
Chauncey. So it's good. Great.
Ooh.
It knows so many things.
Wire song. Arrow. Project Arrow.
Yeah, that's.
We're against our like wire. We're not advanced. Yeah, it's just not mixed up. Yeah, they can check to YouTube it. Yeah, that's good. So to me, this is going to probably be a type 2 use. Is this Adobe Max Arrow, I should say.
The cars are really popular.
So that's a magic leap there. Those ads everywhere. I love marketing videos. So let me ask you guys now, what sorts of AR are you guys envisioning that you might want to what furniture is interior?
I was gonna say, like, I'm wondering if is there like an app or something that I could design, like lay out, even though it's simple as like lay it on the space, just like furniture, like what different wall color, and you could actually be in that room, you know, in that room, like renovate, you know, kind of, it knows the
You look
scale
at
of the
that wall
wall.
and you're like, I want that pink color.
Mm-hmm.
Maybe not necessarily like
It's a
wow,
good-
you're augmenting it, but
Yeah.
like a high layer.
Well, yeah, if you want to take notes in this space, I was just going to show you this one here called Just Align. This is an app that Google made as an experiment, but you can walk around a space and talk into it and record a screen capture for people to look at later. And all it is literally just a line. You just type, you just draw on the screen. You could just annotate space. You're like, okay, we're gonna have this over here, you know, and this over here.
But it'll stay in the space like what you.
Yeah. Yep. You can walk around a whole house and it'll remember everything, as long as you don't move the camera too fast.
Yeah.
Motion blur will wreck the tracking. I guess I can just let this roll without the. I have an AR playlist that I keep up to date as well. See if I can dig this up. So this is something I wanted to show you guys. This is something I did with the HoloLens where I embedded a video. So it's not a 3D object. This is literally just something I did in Unity on a Friday night after work. Pick it up. But if you notice, like, the video is going to have a rectangular aspect ratio. Someone in Mass, Princess Leia, on YouTube, and I just downloaded the video. Not working. So there's a button right here where you just need this. Sometimes that will shut it on. Here's the dog. Yeah, it's lost. There, everything just popped back up. So
With all the moving people and stuff, it might have said this like.
if I cover these sensors, yeah, right there, it just said finding space. So it got lost. So when you pick it up, you might accidentally. It's not a big deal. Yeah, they just found it again. But sometimes you just gotta kind of show it around.
Like, if a person walks in front of one of the objects,
It's not fast enough. The slam tracking doesn't update fast enough to include. But if you hold your hand there for like 5 to 10 seconds, yeah, you will eventually include the object. So what I was saying about this video is, when you look through the HoloLens, it's essentially a projector, right? So if you have a black backdrop on an image, it's going to appear see-through. So then Princess Leia, I just, in After Effects, make her more white, blue color, brighter, so that it showed up more in the HoloLens. If you think about a projector, if you shine one on a wall, like a checkered color, or stripes that are black and white, you take like a light meter, you put it in the black, it'll barely register any light hitting the light meter. If you put the light meter in the white, it'll just go all the way to the top. So these are concepts that you can kind of use in augmented reality. I want to show you guys a playlist that I keep, and I update this quite a bit for XR. Some of these are VR related, but there's so many creative folks out there. Doing things on, the social medias, right? And it's a good call to keep up with that stuff because it'll teach you, like, what people are thinking. Now, a lot of this is VR. Let me see if I can find some of the latest stuff for AR. Unity one. So lighting is also a concept that people need to consider. So this is in Unity and their new AR Foundation plugin. It's taking in the visuals of the real world and putting them on the shader surface. So it's actually taking reflections and simulating the reflections. Okay. So I'm going to move on from this. There's something else I just thought of I want you guys to see. HoloLens. 2017. So as we enter more and more into a world full of smart machines, one of the really interesting use cases will be machine intention visualization. So like, you guys ever seen a Tesla pick somebody up, like with nobody in the driver's seat? You can actually rate, if you have a Tesla, you can actually, if you're like in a front of a restaurant, you can like summon your Tesla and it will come out of the parking spot and come to you, right? Yeah, exactly. But it's one of those weird features that people just like. But I guess what I'm trying to say is like, as we become a society with more and more machines that can do things on their own, robots or cars, whatever, people are going to want to know what the intentions of that machine are, because then you can see its mistakes before it makes those. So let me see if I can find this video for you. It's actually from an older talk, so I actually will bring up those slides. Yeah, so I'm hearing on the HoloLens, you might hear the chimes. That's the ballerina dancing right here. So if you want to shut that off, just look at her and do an air tap. So I guess it's not on that slide deck. Let's see if I can find it. HoloLens. Announcement. It's the original announcement for it.
Oh, the original.
Might be this. Yeah, it's this. So this guy's name is Alex Kipman, and he's now famous because of the HoloLens itself. He's sort of one of the leads on the project. You're welcome. Thanks for coming. I think that I'm not going to find this, but that's okay. What I'm trying to say is there's a robot they have on stage during this, and like the robot's supposed to make decisions, and it goes from point A to B, and then somebody stands in front of it and reroutes. And you can literally with the HoloLens watch that sort of be reroute, basically based on the processing that's happening on board on this robot. So I think I'm done for the day as far as like demos on here, but I'm going to stay around. If anybody has any want to have like more informal conversations and stuff. I'm based in Indianapolis, so it's probably good to talk to me while I'm here. Otherwise, you can contact me through BizHelp, which is right here. Thanks, guys.
Sure.
It's a custom app I made. I call it the we have named for it here. Yes, right there. Reconfigurable IQ.
Oh, there's a, yeah, I couldn't find a space tab.
I didn't say it.
Yeah, I didn't space tab.
It should be floating right over Matthew there.
How close do you think we are to like actual?
There's a company I follow that called Lightfield Labs.
There are several volumetric displays out there, but they have to hit a medium isn't quite the right word. They have to hit something that then reflects the light back into your eyes. So you've got some sort of substrate, or for lack of a better word, a screen Even
Yeah,
though
it
that
seems like on a
screen
glass
can be a
box
bunch of
type
stuff.
thing.
Well, there's that stuff, there's slices, so this is
Yeah.
a series of slices that are
So
projected
kind of like what I was
onto.
asking, so.
You can have
So if we
screens
were
that
to
are
use
flat,
this and
but
our studio
it's
projects,
spinning, so it's
what
around,
the
it's
best,
around,
like,
it's a circle
For an exhibit,
screen, a flat circular plane.
I mean, just
So it's spinning
design
on
is
its y-axis
you're running the device,
inside of
I
a
say
globe
Sketchfab.
to protect it.
The problem with
And
Sketchfab
then
is it's not
there
like
are
paying for exhibits.
projectors
So
arranged
you're
in
gonna
the
make
base, and
you
there's
might
a
look at that.
stepper motor, so it knows when the screen has a particular orientation.
It'll let you sort of.
And then the
alter
projector
the
just
content
puts
and it'll
pixels
help you out.
per particular areas on the screen at a particular orientation, because a projector can only project X, Y.
Yeah, there used to
The
be a
moving
thing out
screen
there
gives you a Z
reveal, literally
with based on timing.
and like it's still.
So like it knows,
It doesn't
so the
let you
computer
see
knows,
things
so
like
a
that.
three-dimensional
So you
picture
have to create.
and it knows where voxels
They used to
need
have
to
it
be
where it's like a
projected
website,
in the Cartesian
troubleshoot it's a URL. It's awesome.
And, but the projector
And it
can only
was
do
meant
X,
for
Y.
tagging.
So it knows, yeah, it's looking at time, and when the screen comes around to the
And then
right
there's that little
position to give it the
line.
Z,
Yeah.
then the projector shoots.
That's just like,
a pixel there,
your
that's
things.
generated
It's
a
like, okay,
voxel.
I want this here,
There's
and then
another
you bring
method
someone
that's
else
a
over.
helical
It would be a
screen,
way
so
to
it's
track
a
your
long
communication.
rectangle
This
that's been
is what I'm saying,
twisted.
you know, this here.
I don't know if it's 180 degrees or 360, but it's a spiral.
You're welcome.
And it's in a cylinder, and
Hope
it's.
you guys find some use out of this stuff.
Yeah,
Projector
I
up
think
front.
we will.
So knowing the shape of the screen and where it is in its suite, again, the projector can only put from its perspective, X, Y, and then the screen's shape and position in time and space provides the Z.
Yeah.
So they're there.
Yeah.
There's also ones that project on, well, what was that pellicle mirror one? It's a spinning mirror
Oh,
at
yeah.
an angle, and then so the mirror's like laid back at 45, and it's just spinning. And again, there's a projector up above. Sometimes for some of these, they're not using regular raster projectors like you would use in a classroom on a screen. They're using something that's projecting vectors, like an oscilloscope. An old school oscilloscope screen is a different type of imager. It's a vector imager instead of a raster imager. They're really weird. But it's using those because it's just basically shooting dots just all over the place as the screen sweeps. So look up volumetric display or volumetric projection. You can get quasi stuff with, Disney does this at Epcot with these sheets of water. So it's got these heads on water tubes that make a fan, spray at a fan. And you can project onto that because the water is opaque enough that it'll reflect the light and you can see it at the screen. Well, if you got a couple fans in different distances from you, you can project on those. Those are slices. So the projection stuff, you have to divide, you have to take your volumetric data and slice it, and then project the 2D slice in the appropriate plane to then reconstruct an approximation of that volume in the display.
This is sort of a hacky way to do it.
That's the one I've seen before, where it's like, I've seen it with even just pieces of plastic, and they put it over there.
Yeah.
Like,
Over a phone or a tablet, yeah.
or something.
It's a, what is it? It's a something illusion.
Pepper's Ghost.
It can do Pepper's Ghost, but it uses the same sort of idea where you've got semi-translucent material that you're projecting on and it's hanging in space. This, yeah, you just got the four.
So this one I have like 4 cameras that are rendering those 4 views. So then you just rotate one object in Unity, and then it's just re-rendering to 4 different outputs.
There's just a little bit of physics here. You know, you can look at the, you got your distance from the projected source to the screen, the angle of incidence, the angle of reflection, and then there's when you're like looking in a mirror, there's your actual reflection of light, and then there's the, what do they call it? The perceived light.
Yeah.
So like if you stand 3 feet from the mirror and look at it, you look like you're 6 feet away.
Must be
Because of the way that the light is working with that, it's going 3 feet out, reflecting, and 3 feet back to the eyes. But it looks like it's 6 feet behind the mirror.
Yeah.
So there's an actual vector of that photon, and then it's, I don't want to use the word virtual then because it's so loaded in this room right now, but then there's the non-existent vector of that light, the perceived vector, which is not true, but it's what you see.
Yeah.
And it's just weird.
This one uses a persistence of vision. There's like literally a piece of plastic flapping really fast. And they just timing the projection with mechanical motion, but it's done so fast that persistence of vision allows it to look volumetric.
You can do similar things with, if you've ever seen that, it's like a stick with a bunch of LEDs, just a single line of LEDs, and it's waving back and forth, and they light the LEDs at the right spot. Yeah, that
There's a frisbee that did that too.
that takes advantage. Yep.
Yeah.
It's really weird. It takes advantage of a physics, because you can do it yourself without the thing moving. It's called saccades. So there's the brief twitch that you can do with your eyes, and then it creates that illusion. So the spinny fan thing means that you don't have to perform saccades. It's doing it externally to you. But it's the same concept. It plays with persistence of vision, because there's only one row of LEDs, but you perceive the display that. So like if you've got a row of, or column, I should say, column of 10 LEDs, but you're swinging it back and forth at the right rate and lighting them up at the right time, you look like you've got a screen that's like 10 pixels high by like 30 pixels or 50 pixels wide or 100 pixels wide. It's only one column. But again, that persistence of vision gives you the illusion of the big thing.
This is a different technique. They're using eco projectors in your glasses. So you're looking at a map. It's retro-reflective. So then you have your unique view because your dim projector hits and go right back in your eyes. And then they track based on the map. So if you look at the map, they're using it as an image target to track your perspective. That was a Kickstarter that was just successful last month.
I would definitely buy that.
I bought one for $350. I mean, it's not cheap, but it's really kind of a unique concept. And I'm looking forward to building things for it. So that's my investment. Is I'm going to build things for it, be ready to show people possibilities, and there's a lot of opportunity here for public exhibits, museums, and stuff.
Well, thank you guys.
Yeah, thank you.
You're welcome.